it's exciting to see so many people here. This has been a fun first day of the conference, and hopefully we enjoy this last talk. I want to talk today about building solid, production-ready SQLite applications on Rails. Before we jump into the meat of the talk, let me quickly introduce myself. Hi, my name is Steven. You can find me on Twitter at FractaledMind. I am an American expat who moved to Berlin, Germany 5.5 years ago. And there I met my wife. We got married about 2 months ago. Thank you. It turned into a bit of an international adventure. We were incapable of navigating the bureaucracy of Germany, so we ended up getting our marriage license in Denmark. But none of our friends and family were able to join us in the town hall in the small town on the border of Denmark. So we planned a destination wedding in Jamaica, and that's where we had the actual wedding ceremony. But we are back in Berlin now with our 2 dogs, which I think have a striking resemblance with the 2 dog emojis. That is Tuck and Ruby, the brown one there. Named after, well, I think you know. At my day job, I'm the head of engineering at a company in Germany called Test.io. But I spend a lot of my time doing open source work in Rails and SQLite and associated projects. And along the way, I write a fair bit on my blog, FractaledMind, GitHub.io. So what I want to talk about today is why this is how I start all of my new Rails applications. And part of my responsibilities at work have led to me starting and maintaining a fairly large number of Rails applications in the last couple of years. And many of them have been initialized just like this. And the first question I inevitably get when I tell people this or I make this recommendation is, why in the world would you do that? Right? Isn't SQLite just for running your local tests quickly? Isn't it just for toy applications? You want to do a quick demo as you're screencasting? Like, why would you actually run a production application with SQLite? And there are actually a number of reasons. The first one is hard to really appreciate until you try it. Like, I recommend you actually take some time, use some of the code that we're going to go through today and experience it, because it is hard to appreciate how different it feels until you're actually using an application where your database is 600 times faster than what you might be used to. These are some benchmarks that were run by Ben Johnson, who is the creator of Lightstream. We're going to talk about that a little bit later. Comparing just doing simple single column writes against SQLite and Postgres in various different configurations. So running Postgres on the same machine as your application, in the same availability zone, in the same region, or cross-region. And as you can see here, when you are working with Postgres, which I think is fairly common, right? We're going to be running a proper, sturdy, resilient Rails application, so we're going to use managed Postgres. And if your application has a multi-region deployment, like definitionally, many of your application instances are going to be talking to Postgres cross-region. And it's incomparable, the performance differences when you're just talking inside of the same process to data that is right next to your application. But beyond speed, there are, I think, many other reasons to consider running SQLite in production. I imagine that many of you, like me, have seen on the internet a growing number of stories of people waking up to these startling cloud bills. Like, what? I oversell $100,000? What do I do? And of course, SQLite itself is free, hard to get much cheaper than that. But beyond that, it is incredibly predictable and cheap to run, right? It's just storage. It's just a file on disk. And it's quite straightforward to see what you're going to need. You can make predictions. You can over-provision. And it's just running on your box, right? It's not some managed service where you're having to pay for every single read and write. And oh my goodness, my application just got popular and now I'm begging on Twitter to have my debt relieved. And in general, if you're trying to bootstrap a project, the free tiers of these managed database services are disappearing, right? The economics have changed, and it's difficult for these companies to sustain offering the compute that is running these managed database services to thousands, tens of thousands, hundreds of thousands of customers who aren't paying them anything. And in fact, one of the last remaining generous free tiers in managed databases is Terso, which is managed SQLite. And for bootstrappers, of course, it's hard to sort of have the cash on hand to spend $40 a month on PlanetScale, for example. In general, if you have been on the internet, been on Twitter, you might have sensed that there's a growing interest and conversation around running SQLite in production for web applications across the web development world. And as more people are exploring the possibilities, more people are coming to see and appreciate that running SQLite in production can really offer meaningful and production-grade performance. It might require a bit of tuning, but we're going to get into all of that here shortly. And for Rails in particular, I think that it is uniquely well suited to the DNA of Rails. DHH in his keynote last year at Rails World re-emphasized the point that at its heart, Rails is a one-person framework. That is, it is designed to give the smallest possible team, right, just you, as a sole developer, product manager, marketer, salesperson, the ability to build feature-rich, economically valuable and viable applications quickly and effectively. And SQLite is perfectly paired with that vision of web development. I think that there are three key characteristics that make it uniquely well-suited for the database of the one-person framework. And the first is that it is truly quite simple. It's literally a file on disk. Your database is a file on disk. And the database engine is an executable that runs inside of your application process. And so everything is contained within your repository. Everything is contained within your application. And those are literally all of the moving parts. And that simplicity brings with it a certain unique amount of control. When everything about your database lives in your repository, naturally, definitionally, all of the configuration lives in your repository as well. And in fact, because it's a single executable that is bundled inside of your application, you actually have the power to control the compilation of that executable through Bundler. And we'll look into that later. And the fact that your database is a literal file on disk opens up unique developer experience possibilities, like having a different database for each Git branch that you are setting up in your application. We'll look more into that later as well. And then, of course, it is like fast. It's weird fast. When you go from measuring queries in milliseconds to microseconds, something changes. Like it's an actual state change. You think about problems differently. You think about possibilities differently. And there are so many stories where people are genuinely surprised at the speed and what opportunities that provides for your application. I'm curious, just as a quick sense here, show of hands, who here is running or has run some sort of application or service with SQLite? Cool. Yeah, I see a few hands. That's amazing. What I hope to do for the rest of this talk is to help the rest of us get more comfortable and get to a place where we feel confident that we could, in fact, run a production-ready SQLite application on our own. So I want to turn from why we might choose SQLite to talk about practicals, right? Like how do you build and maintain a production Rails application backed by SQLite? And I need to make a very clear point So if you've been drifting in and out, come back. We need to be on the same page here. This is important. Running SQLite on Rails out of the box is not viable today. If you run that command, Rails new database SQLite, right now, you take that application, you build out your features, you deploy it to production, you are going to experience pain. It is not going to feel good. You're going to be like, that Stephen guy, what an ass. There's all these bugs, and this is not working at all. Now, I will say, it is my express goal to make this statement true for Rails 8, and we are close. There's 2 more pull requests that are almost ready to be merged. I think we're going to get there. But as of right now, it is not viable. So I need to walk us through what it takes to make our Rails application production ready, to make it solid. So what do you need? What are the absolute must-haves to get your application into a production state? Well, luckily, it's pretty simple. And this here, if you don't get anything from this talk except one slide, let it be this slide. Take a picture with your phone, take a picture with your mind, whatever you need to do. These 3 commands take an unviable Rails application and make it a viable Rails application when you are running SQLite. And we're going to go into more detail of what they do and why they do it, but the short version, TLDR, you don't need to listen, you don't need to read. Run these 3 commands. Run Rails new, then run those 3 commands. Things are going to be so much better. But let's talk a little bit more about what's involved, and let's go a step beyond what's just necessary and talk about what all is possible. We're going to cover 5 key points. All right? What it takes to make your Rails application performant, how to integrate the solid gems that are going to be the new default adapters in Rails 8, what data resilience looks like and what we need, how we can then enhance our application and our developer experience, and what the constraints and possibilities are for deploying our application. Now, for the rest of this talk, there's going to be a lot of code snippets on the screen. And I'm not going to be going particularly slow or particularly deep. So don't feel stressed. The slides are all online. You can come back and reference them. And there's no need to feel rushed. Let's start with performance. Now, there are 5 things that are going to take your Rails application from not very good performance at all to, hey, this is feeling nice. These are the 5. If anyone here happened to have been at Wrocław RB earlier in the year, I gave a talk there where I went in depth into these 5 points. What precisely they are, what the problems are, what the code is that we solve them. I took all of those slides, I fleshed them out into a blog post. That is what is linked in the QR code. I don't have the time. That was an hour-long talk. I don't have the time to redo all of that. So we're just going to say, this is what you need. If you want to learn more, we can talk about it later. And you can also read that blog post. It's got a lot of pretty pictures and covers everything that is here. The key point is, how do we make this true? Well, the first one is true by default in Rails as of Rails 7.1. That's nice, right? So we want to get to a place in Rails 8 where the first 4 of these are true. It'll be a while till the 5th one is true, but the goal for Rails 8 is that the first 4 are true by default. But until then, that is what the enhanced adapter is going to be giving you. It enhances the SQLite adapter, making these 4 performance characteristics, these 4 requirements to have a higher performing Rails application that is backed by SQLite true. And again, all of the details into like what precisely it's doing, what code is there, that's in the blog post. I just don't have the time to go deeply into it. If you want to have isolated connection pools, just to really briefly give you the explanation of what that means. By default in our Rails application, we set up in our database YAML, we're going to be talking to production.sqlite3. Rails is going to spin up a connection pool. And by default, it's going to put 5 connections in that pool. SQLite has a restriction of only allowing one write operation at a time. And when you are in write-ahead logging mode, that's that first point, that's true in Rails 1, you can have only one write operation at a time, but concurrently you can have functionally infinite read operations occurring concurrently. Well, that's nice, but if you have one connection pool to your database, what happens when you get 5 requests come in and they're all doing a lot of writes and your connection pool gets saturated with requests that are trying to all write to the database, and you have 5 other requests that are 5 read requests, and even though SQLite itself is perfectly capable of serving all of those read operations at the database level, you're going to be bottlenecked at your connection pool. And so if we isolate those connection pools, we have one connection pool for read operations on the database and one connection pool for writes, then we can remove that contention, remove that bottleneck, and allow our read operations on the database to happen concurrently with write operations at the Rails layer. This is a somewhat experimental feature, which is why the gem requires you to opt into it, but it's a single configuration. That's all you need for performance. It really is as simple as add the enhanced adapter gem, and your application will go from not so performant and lots of errors to very performant and no errors. And again, for all of the details on that, I wish I could go deeper into it. It's a really fascinating topic. You can talk with me later or check out the blog post. Let's turn to the solid gems. These are the gems that are going to be made default, the default adapters in Rails 8. So we've got solid queue, solid cache. They'll be making solid cable. What does it take to use them with SQLite? Right, let's go all in on SQLite. Well, first things we need to do is just add them. We'll talk a little bit about what solid errors is in a bit. But add the gems, mission control jobs, that's the web UI, so that you can have observability into what's happening with your background jobs. But after we've added the gems, how do we configure them? How do we set them up? And what are some of the pain points? Well, when it comes to solid queue, and this is going to be true of all of them, the key detail here, the key move we're going to need to make is to take advantage of the fact that SQLite is a very simple and lightweight database. And so while the customary move, right, what you'll see in the documentation, what 37 Signals has talked about when they are talking about these gems, is like they are imagining you've got one big chunky database and then you wire a bunch of services up into it. So they've got their big MySQL instance, and that big MySQL instance has all of their application data, and it has all of their job data, and it has all of their cache data. And like, sure, physically it's sharded and distributed, but logically there's just one database. We don't want to do that with SQLite, primarily because of this restriction on linear writes. Right? We're going to have contention. We're going to want to be writing application data and writing job data, and they're going to have to wait and queue up. And that's going to kill performance, and it's not particularly useful. All of us are used to running Sidekick. And you know what's true in Sidekick? Your Redis database doesn't know anything about your Postgres database. And your Postgres database doesn't know anything about your Redis database. We've gotten comfortable with this arrangement. Right? These are trade-offs, but they're trade-offs that we know about and we know how to work with. So let's just replace our Postgres database with SQLite, replace our Redis instance with SQLite, but have them be completely separate databases. This removes any and all contention, quite nice, but it keeps the operational simplicity that SQLite is so uniquely able to offer us. So how do we set that up? How do we set up a separate database to back these different services? How do we install these gems to use that separate database and get everything wired up? Let's walk through the code that is needed. So the first thing we need to do is in our database YAML, we need to declare a new database. That is just defining a new key. So we need to go from, you'll see in the Rails docs they use the language of moving from a 2-tiered database YAML file to a 3-tiered database YAML file. So we're going to explicitly define our primary database. This is the database that holds all of our active record model data. And we're also going to define a queue database. This is going to have a separate set of migrations, so we're going to define a separate migrations path. And it's going to have a separate actual file, so we're going to define a separate database. And then in our different environments, for the sake of simplicity and having big enough text, I'm only showing development here, but you would do this in production as well, right? We say we're going to have our primary database and our queue database. So now Rails knows about the fact that we want to work with multiple databases. They're all going to be SQLite, but they're separate entities. So now that we have this queue database, how do we wire it up with SolidQ? So when we run the install generator, we need to make sure to tell SolidQ that we want to install it for the queue database. So the database environment variable does that for us. And then when we run the migrations, we want to tell Rails, migrate the queue database, not my primary database or all of my databases. This gets the actual database migrated, all of the tables, everything set up. But we then need to tell the Ruby part of SolidQ that it needs to talk to that database that we have now set up. So for SolidQ, we need to tell active job this is going to be our queue adapter, and we need to configure SolidQ to connect to our queue database. If you only supply the writing key, the reading key is inferred. We're just going to do all reading and writing against this database. Those are the 3 things you need to do. You set up the database. You make sure you get that database in your YAML file. You get that database migrated. Then you configure the Ruby code to talk to it. SolidQ comes with its own configuration file in YAML. This is where it lives and roughly what it looks like. Here's an example of running a recurring job. And we'll actually see that job in just a bit, what it would look like to verify our Lightstream backups in a recurring manner. And that's all you need to know about SolidQ. Let's talk about Solid Cache. I'm going to move a little bit faster now because it's going to be the same process. We're going to define another database. This is one of the things you're going to start to get used to. SQLite, embrace the databases. Let's have 5. Let's have 15. They're tiny little files. And Rails multiple database support is quite solid now. Define another database, we'll call it cache, has its own migrations, has its own file. Now we have 3 databases in our environments. We want to run the same stuff. When we install Solid Cache, tell it about the database. When we migrate it, tell it about the database. For making sure that you are actually running caching correctly in development, you need to tell Rails that you want to do caching in development. That's the command. And Solid Cache has its own configuration. This is a slight difference between Solid Cache and SolidQ. Don't ask me why. But in order to tell the Ruby which database to talk to, this key in the YAML file is important. So this is going to be an edit from what is created for you when you run the install command. So you need to manually go into this file and manually make this change. But those 3 things are done. We've configured the database, migrated the database, pointed Solid Cache to that database. Everything is good to go. Now, let's talk a little bit about solid errors. This is not a gem that's going to be default in Rails anytime soon, I presume. This is a gem that I wrote that expands on this basic idea. Once you do this a couple of times, I had this realization. What are we really doing here? I have some service where I need to store data, and I want to have some way to observe that data. And all I really need to do to wire that up in Rails is take those 3 steps, and I can just make a little Rails engine, put some views in there, have some routes, have it mounted, and I can sort of give myself access to whatever data I need. What might be some interesting data I might need? Well, errors. Rails has the error reporter. It's very easy to define a subscriber. So what if we just defined a subscriber that all it did was write into a SQLite, into any database, But in this case, we're talking about SQLite. And then just mount a Rails engine, and you can just read that data. So instead of sending it to a third-party API, you're just persisting it right next to your application. Setting that up, same process, more databases. I have one application that has 6 databases in production, and if I'm lucky, I'll get to 8 one day. That'd be cool. We run the installer, run the migrator. We configure it pointing to that database. This is the additional configuration that you're going to need. You can have the gem actually send emails when errors occur so that you are alerted when they happen. And you put all of these things together and you're starting to get a picture here, right? Rails with SQLite offers you an incredibly cheap, like the stuff we're talking about, this is free. This is just rent your server, and there's no other additional costs. And you get, of course, not full-featured, not as complete as these paid alternatives, but you get viable alternatives for all of these different I/O-bound services that Rails applications have. And we could imagine more, right? They're going to work on solid cable so you can back action cable with a database. And of course, we could back it with a separate SQLite database. I'm working on a gem called Solid Metrics. Same idea. Here's some interesting data I would like to have and I would like to view. What if I build a Rails engine, pipe it into a database, read from that database to show you a view? We could do really basic APM on top of Rails instrumentation. This is the vision and what I mean by solid SQLite on Rails applications, leaning into this philosophy of what's possible when you marry Rails with SQLite and when you embrace the idea of just spinning up as many databases as you need. No concurrency issues, no contention issues, easy to keep everything right next to your application, incredibly cheap to run. Like, this is a bootstrapper's dream. That's all you need to know about solid gems. Let's turn to resilience. Let's imagine we've got these 4 databases. Everything's running. We've got solid performance. Things are looking great. We're all worried about the same thing at this moment, which is, this is nice and it's cheap, and I appreciate that I was able to bootstrap this. But if this server goes down, I'm having the worst weekend of my life. And I want to be very clear, you would have the worst weekend of your life. I know that because, yeah, I've deleted my production SQLite database before. And I didn't have a backup strategy in place. And it was the worst weekend of my life. And that is why I make sure to say very clearly, data resilience is a day 1 requirement. And I spent a lot of time thinking about how can we make this as easy as possible, because nobody should put an application in production running with SQLite and not have a backup strategy in place. So let's talk about what we have in the Rails ecosystem to make this easy and solid. My tool of choice is a tool called Lightstream. I mentioned the creator of Lightstream with the bar chart before. This is going to stream the writes to your SQLite database or databases, as many as you need, to any S3 compatible bucket storage, or if you really want, you can set up your own SFTP server and have it stream things there. And then you can just pull it down. It gives you point-in-time backups, and it is incredibly simple to run. It's incredibly simple because it's just a single Go executable. And what's really nice about single executables is that it's pretty straightforward to just wrap them in Ruby gems. So I've created the Lightstream gem, which wraps that executable and exposes its APIs through Ruby. So you can add that gem and run the installer, and you're good to go. That installer is going to create 2 files for you. The first is the configuration file for the Lightstream utility itself. This is what it reads to do its job. And it is here where you tell it, what are all of the databases that I want to be backed up, and where do I want to back them up to? What the installer is going to do for you is it's going to introspect your database YAML file, find all of the databases that are SQLite databases, and generate a Lightstream configuration file that says, I want to back up all of them, and I want to point them to some undetermined through environment variables replica bucket. So then how do we set up these environment variables? The installer will also create this initializer. And this is going to allow us to manage the credentials for Lightstream that it needs to run through Ruby. And by default, it doesn't do anything. It just has some commented out code, but this is the code that is commented out. This is like the simplest default recommendation. Just put it all in Rails' encrypted credentials and bind them here. When you have these things set up, so you've put your credentials into the Rails application credentials, how do you start backing up your databases? You just run this rake task. This rake task is going to start the Lightstream process. Lightstream runs as a separate process. So however your application manages running multiple processes, add this process. The gem defaults to imagining you're just going to have a proc file, and it'll spin up a little proc file for you and put it there. If you're doing something with Docker, run it. Just run this rake task. When you start your Rails process, start your Lightstream process at the same time. Once you start replicating your database, how do you then restore it? It's a simple rake task. Call restore, and you just tell it which particular database do you want to restore. Right? In our case, in our example case here in this talk, we have 4 databases. So you have to be precise. And this is quite nice, and you can run this, and it'll work. But I imagined as I was preparing this talk and doing this work, like, is this enough? Is this enough for me to sleep soundly at night? Maybe not. What else could we do? What would ensure that I'm sleeping comfortably and peacefully? Well, what I really want is I want to verify that my backup process is constantly working. What does it look like to verify it? I want to make sure that my replicate process is on. I want to make sure that when there are changes to my database, that replicate process puts them in S3 or equivalent. I want to make sure that when I restore a database, that database file is a valid SQLite file that I can open. And I want to make sure that the change that I made is in that new file. So I wrapped all of that up into a simple method, Lightstream verify. Give it a database path. And what it's going to do is going to make sure that there is a Lightstream verifications table in that database. Create table if not exists. And then it's just going to put a single record with a UUID in there, just a little sentinel. And then it's just going to sit back and wait for 10 seconds. And after 10 seconds, it's going to run the restore command. And it'll then open that restored database file and check, is that record in there? And if all of those things are true, then we verified all the things I just wanted to be true. And if something goes wrong, we throw a verification error. So it's super easy to wrap that up into a job, iterate over all of our databases and say, I want to verify that backups are working. And we saw already before with solid Q, super easy to turn that into a recurring job. You can run that every day at 1 a.m. You can run it every 15 minutes. You can run it however much you need to feel comfortable and confident that your data is indeed being backed up consistently and constantly. And if you have solid errors and you've configured it to send emails and something goes wrong and the error is thrown, you'll get an email and you'll be like, oh, something backup wasn't verified. Let me go in and look immediately. All without having to pay for an external service yet. Again, a bootstrapper's dream. The gem even comes with, I've fully embraced at this point, let's have Rails engines and provide observability through the web UI. So wrapped up a very simple web UI, show you what's going on with the Lightstream process. I won't walk through and describe everything that's there, but this is how Lightstream slices up the world and makes sense of it. Data resilience, not too bad. It's just add a gem, set a few things up. You can get a really solid backup system in place. Let's talk a little bit about enhancements. The enhanced adapter gem, it doesn't just give you improved performance. It brings some features that are in newer versions of Rails, but not like in 7.1.0. It brings a few features that aren't yet in Rails 8, but are coming, and brings some features that might not ever be in Rails. Who knows? Let's talk a little bit about them. I'm going to move more quickly now. You can have deferred foreign keys. This is something you might not have ever known about. You don't really know about it until you need it, but when you need it, you really need it. SQLite supports it. Active Record supports it. Active Record and SQLite don't yet support it. They will soon, and they do through the gem. You can also do virtual columns. I remember when this came out for Postgres, I was like, oh, that's so cool. I wish SQLite had that. I went and looked at the SQLite docs. They've had it for 15 years. I'm like, what? Yeah, nobody just cared enough to add it to the Active Record adapter. I added that. When you have virtual columns, this is a newer feature as well. If you might have seen this, if you're using this with Postgres, you make a create command, post create. You've got a few virtual columns there. The record that comes back, the values for those virtual columns have been hydrated automatically right there. How does that work? Under the hood, that is using the ability to specify the returning columns that you need when you write something to the database. And you can use that manually with insert. This is another feature SQLite supports, Active Record supports. We just need to bind them together. You can also specify pragmas directly from your database YAML. All of these features, right? These are Rails features. They just aren't fully distributed to all Rails developers of all Rails versions. If you are running Rails main right now, all of these things are there. But if you're running Rails 7.0 or Rails 7.1.0, some of these are and some of these aren't. This one isn't in Rails, and it won't be in Rails 8, but adds the ability for you to load SQLite extensions from your database YAML as well. I just don't have the time to go super deep into that. Another blog post on that. But SQLite extensions, there's many of them. There's a package manager. You can expand and extend the capabilities of your database in many different ways, like adding the ability to have UUIDs, for example. As I talked about before, what are other ways that we can enhance our experience with SQLite? Well, we can fully control the compilation flags. And we can do it all through Bundler. It's not a lot of magic. And there's a whole documentation page for SQLite on what all the different flags are and what they do. This is my personal set. These are the 7 that I run. Blog post on why these 7 and what they do. What about database branches? Here's a fun one. Who here has ever had the problem, you're working on a feature branch, it's taking you a little bit of time, maybe you've been working on it for a week. You're almost done, but not quite. And on Friday, your colleague pings you, like, hey, I'm really trying to get this merged, man. I could use your help. I need you to give me some review. You check it out. You're like, sure, no problem. Not even thinking about it. Hop into your terminal, git checkout, colleagues feature branch, and check everything out. Everything looks good. Thumbs up. They merge, go to production. Awesome. You check out your feature branch. You pull up the app. You're testing it. You're in your local development. You're like, huh? Why am I looking at this error screen? Everything is blowing up. Nothing is working at all. You take a step back. Right. I added a migration in my feature branch. They added a migration in their feature branch. I ran both of those migrations. My database now has this merged state, but my application in code for my branch doesn't account for their change, and it's borked, and nothing's working. If you haven't experienced it, you will, and when you do, you'll be like, this is so annoying. It would be so much easier if we just had completely isolated database states. Like, what if we just had a different database for every Git branch? And what if it was easy to move data between them? What if it was easy to make sure that all of our seeds were set and all of our migrations were there? Well, you can get really far with these 2 lines of code. Run a little bit of ERB and bash in your database YAML file. Throw this in your development initializer. And every time you change branches and you run a Rails command, you call the console, you start the server, you run Rails runner, you do db migrate, like whatever, it's going to call the Ruby code behind the db prepare rake task. Right? It's going to make sure that that file exists. It's going to run the migrations. It'll run the seeds. And if you want some extra spicy goodness, I have some more code to make it easy to move data between branches. You can have your feature branch. You've built up all of this test data for your local development. You switch into a new branch. You want to bring it over. You can find more in that blog post. It's a super nice enhancement to developer experience. And it's hard to go back, honestly, once you experience it. Deployment. Here's the key thing to say. You can't deploy to Heroku. Full stop. There's no hacks. Don't try it. It won't work. Lots of pain. Doesn't work. So what do we do instead? Well, my personal favorite and what I use all the time, Hatchbox. I find it just about as easy as Heroku and not very expensive. Run by Chris Oliver of Go Rails. I have a whole blog post. I walk through literally every single step, every single screen on how to deploy an application that is using SQLite, using Hatchbox. It's not very complicated, but as with all of these things, there's just a lot of screens, but you can step through it on that post there. More recently, of course, we have Kamal. There are various blog posts you can find on the internet. You can just Google Kamal SQLite. You'll find different options, different guides on how to do that. I personally really enjoy not messing with Docker, and the simplicity, the operational simplicity of Rails plus SQLite doesn't require me to use Docker, so I don't use Kamal. But other people do. You can find plenty of resources there. In general, what that is going to look like is just go rent a VPS. Go to Hetzner, go to DigitalOcean, go to Vultr, rent a VPS, put your code on it, and run it. That's really all you need to know about deployment. So, we're done. We covered a lot of ground, but I think we did great. I saw it in your eyes. Almost all of you were locked in, yeah. But almost everyone else, I kid. If you happen to really be interested in this, and you really want to know, how do I do this for real, in production? I do have an ebook where I literally walk through every single thing you type into your terminal, every single change you make in your application. And there's a lot of extra goodies, like the stuff about data, moving data between different Git branches and the different separate databases, all of the code for that, everything there, how you want to put it in bin scripts, and which chmod command you run to get it all set up. It has everything. Every single thing that I know about running a SQLite application in production is in that book. If you want it, you can find it at that URL. It'll help pay for my next vacation, which would be greatly. My wife would wildly appreciate that. Again, if you want these slides, they're on speaker deck. Other than that, I really hope that you now have the foundation to start to feel the same kind of love that I happen to feel and DHH happens to feel. Not to say that you should love it just because we love it, but we are really cool. And you feel comfortable and confident to run a solid SQLite in production application in production. I think I said that part twice. Thank you.